So on this first problem, the first step is writing the system of equations, and most people did pretty darn good with the equation where they were describing the cost or how much you spent on fruit. So the $12 on fruit, $4 a pound on strawberries, and $1.50 a pound on rhubarb. And so most people correctly got something like 4x plus 1.5, $1.50 times y equals $12. A few people wrote an inequality. This one's just a systems of equations problem, so you don't need to write an inequality for this one. That's on the next page. People did struggle a little bit with the second equation, the one that dealt with the relative amounts of fruit. And so a little context, rhubarb, super sour, but delicious. Strawberries, super sweet. And so usually there's just a little bit of rhubarb in strawberry rhubarb compared to the amount of strawberries. So where it says the amount of strawberries is twice as much as the amount of rhubarb, that means like if you had, let's say, a pound of rhubarb, you would have 2 pounds of strawberries. If you had half a pound of rhubarb, you would have a quarter pound, or sorry, if you had half a pound of rhubarb, you would have 1 pound of strawberries. So the amount of strawberries is always twice the amount of rhubarb. The amount of rhubarb is half the amount of strawberries. So there's 2 ways you could write that equation. Just translating it right from the problem where it says the strawberries are twice as much as the rhubarb. If x is our strawberries, x would be twice as much as y. The most common mistake I saw in this is people did y is twice as much as x, and that is not correct. That says the amount of rhubarb would be twice as much as the amount of strawberries. If you want it in slope-intercept form, though, and I think that's what people were going for, is they're usually writing it y equals mx plus b. If you want this in slope-intercept form, either you have to switch what your x and y are, or you could write this as y equals 1/2 times x. So both of these say the strawberries, the one on the top, says strawberries are twice as much as the amount of rhubarb. The one on the bottom says the amount of rhubarb is half the amount of strawberries. So either of those would work and give you the same values, the same equation. So then graphing these, if we have strawberries here and we have rhubarb on our y, a good way to set this one up, the way I did it was, well, first of all, figuring out the intercepts. That kind of determines where this one needs to go. The top equation, so the intercepts for this one. The x-intercept when y is 0 would be, y is 0, x would be 3. And the y-intercept for that one, when x is 0, y would be 8. So that gives us our 2 intercepts. So graphing this, I wanted to make sure that my y-intercept goes up to 8, or my y-axis goes up to 8. My x-intercept only has to go out to 3. And so setting up my axes on this one to spread that data out, I did counting by quarter pounds. So there'd be 1 pound, 2 pounds, 3 pounds, 4 pounds of strawberries. Now on the rhubarb side, I counted by half pounds. So this would be 2 pounds, 4 pounds, 6 pounds, 8 pounds. And so to graph these, first of all, for the green one, the one in standard form, you just graph those using the intercepts. So what this means, remember those intercepts, is the x-intercept at 3, that would be the pounds of strawberries you could buy for $12. If you only bought $12 of strawberries, you'd be able to buy 3 pounds of strawberries at $4 a pound. Or you could buy only rhubarb. So spend $12 on rhubarb. $12 would get you 8 pounds of rhubarb at $1.50 a pound. And so that gives us Okay, so remember each point on that line is a combination of strawberry and rhubarb poundage that would cost $12. We're looking for the combination that would cost $12 and have the right ratio of strawberries to rhubarb. So then we want to graph the other line. So a couple ways to do this. If you did x equals 2y, you could just pick a y value, calculate the x value. So let's say y is 2. So if y was 2, you're up here, then that means x would need to be 4. So one of the points on that line could be 2, 4. So the amount of strawberries is 4 pounds, the amount of rhubarb is 2 pounds. That fits the bill of having twice as much strawberry as rhubarb. And if y is 0, x is 0, so this one goes through the origin. If you wanted to do this as a slope-intercept equation, y equals 1/2 x plus 0, then you could just go up 1 pound over 2 pounds. So up 1 over 2 pounds, that would put you here. Go up another 1 pound in rhubarb, go up 2 pounds strawberries. That's that same point that we got for the other one. So you get a line that looks like this. So the next part is to estimate the solution. So estimate the solution using the graph. So before actually doing any algebraic stuff or checking this in Desmos, practice using that strategy of finding the solution to a system by using your graph. And so estimating the solution would be looking for the intersection point of the two lines. So that point right there, that red line or the red point is the point where the strawberries are twice the rhubarb and it would cost exactly $12. So looking at that, it looks like that is about 2.5 pounds. So looking at that point, it looks like X, the amount of strawberries, is about 2.5 pounds. And that means rhubarb should be about half that, or 1 1/4. So if you go over here, 1 pound would be there. It looks like it's just over 1 pound. And again, using the logic of the problem, if you have half the amount of rhubarb as strawberries, then if you divide that by 2, you would have 1.25. And that looks about right using the graph. And then we want to solve that. We want to solve this system of equations algebraically. So with all the strategies we have, with this system, the easiest one would be substitution, because one equation is solved for one variable, so x equals 2y or y equals 1/2 x. We could use that substitution. So taking the one in standard form, 4 times x plus 1/2 y equals 12, I'm going to take that x and I'm going to replace it with what x is equal to. So I'm going to take what x is equal to, which is 2y, and substitute that in. And so what we end up with when we simplify this is 8y plus 1.5y equals 12. Combining like terms, you get 9.5y equals 12. And then dividing both sides by 9.5. We end up with y equals 1.263, which notice fits what our estimate was, about 1 1/4 pounds. And then to calculate x, you could just take that. Remember, x is twice y, so you could just take that and multiply it by 2 to get your corresponding x value. So x ends up being 2.526. And remember, you can always double check these on Desmos as well. Okay, so there is problem number 1. Moving on, these are just solving these systems of equations using substitution or combination. So remember, one thing we talked about is choosing the most efficient way to solve these. And so on these, you can make any of these work for substitution or combination, but there's usually a way that avoids too many steps and avoids too many messy numbers. So on this one, notice the top equation is already solved for y. So y equals negative 1x plus 3. So this one's all set up to use substitution. So what we're going to do, use my color coding, is we're just going to replace y in the second equation with what y is equal to from the first equation. Because remember, the goal is to get one variable equation out of two variable equations. So we can find the value of one variable. Once we have that, we can calculate the value of the other variable. So on this one, we've got 4x minus 4 times, instead of 4 times y, we're going to replace that with what y is equal to from the equation above. Negative 1x plus 3. Everything else in the equation stays the same. So that's what the substitution step looks like. The next part, remember, is to simplify. So now we've got 4x minus 4 times, we're going to distribute. So negative 4 times negative 1, negative 4 times 3. And we will get plus, because negative 4 times negative 1 is positive 1. So plus 4x minus 12 equals 4. Combine like terms. 8x minus 12 equals 4. And fast forwarding ahead, because my video is limited to 15 minutes, hopefully this will fit, we end up with x equals 2. And once you find the value of x with this one, once you have the value of x, then you want to calculate the value of y. So we're just going to put that into the other equation. So y equals negative 2, it's just replacing x with 2, plus 3, which equals positive 1. So our solution to this one is 2, 1. Remember, you can always check those using Desmos as well. So the second system, those are both in standard form. You could turn the bottom equation into slope-intercept form. So subtract 3x from both sides. You would have y equals negative 3x plus 1, and you could do the same thing we just did for problem A. If you like combination, though, and it's good to be sort of fluent in both of these, you can also multiply one or both equations by something so that you have a matching term. X's or the y's have a matching value, and then you can use one of those combination strategies to cancel out a variable. On this one, because it's nice when we only have to mess with one of the equations, we'll leave the top one the same. X plus 5y equals 18. But on the bottom one, I'm going to multiply both of my, all of my terms by 5. And so if we do that, we end up with 15x plus 5y equals 5. So now we've got that matching term. Our matching term is those 5s, and they have the same sign. So what we want to do in order to cancel those out so that we have one equation with one variable which we can solve for the value is we want to use a combination by subtraction. If we used addition, we would end up with 17x plus 10y equals 23. That doesn't help us. But if we use subtraction, what we end up with is negative 13x plus 0y, there's that canceling out, equals 13. Or negative 13x equals 13, x equals negative 1. And then putting that x value into either of those equations and solving for y. Remember, this is the x value at which those two lines would cross. If we graph them, the x value of the xy pair that these both share as solutions. If we put that x value of negative 1 into either of these equations, you're going to get y equals 4. I'm kind of skipping over that step, assuming that that is something we can all do. So y equals 4, so there's our solution, negative 1, 4. All right, moving on to our one variable inequalities. Remember these, you're trying to find the x value that doesn't make the equation true, but the x value that is the boundary of the x values that make the inequality